Okay, well, if we've exhausted the questions, this is a perfect segue into, I think, Don's presentation. But Gordy, back to you first.
Yeah, no, this has been great. Thanks for everyone for the feedback, and keep thinking along those lines, because Don Berchoff has graciously agreed to present at our request. And really, the focus, what we're looking for is, what is the industry doing? As Kevin eloquently pointed out, we are behind the power curve. We are very behind the power curve, trying to get a handle on this and establish any sort of weather standards for UAS. We know the industry's done a lot of very good things, but it needs to be cost effective too. And we know the VWAS is not cost effective to roll out to every location, but we got to keep our eye on the ball and not just fix one part of aviation. We want a total solution here. So that's one of the things the FAA has always looked at is we need to look at all the operators. And so there's definitely some potential here. But anyway, Don, you're up.
Well, thanks. I'm assuming you're going to flip the slides for us. I'm
your slide flipper, Don. This is Matt, but only if you show your video. If you don't show your video, I don't flip your slide.
Okay. All right. Here we go. You can see my long hair. All right. So thank you, everyone. First of all, I want to say that I'm really impressed that I think we've made a lot of progress since the last FPAW meeting. I really believe that, folks like Marilyn Pearson and Kevin Johnston and the work they're doing, and Gordy, and we are starting to see now the integration of industry, academia, and the government coming together on this. And this is not going to be a government show. This is going to be a multi-pronged show, because the challenges that we have to meet here are not, nobody has all the capabilities to do it on their own, right? So I think that's going to be the success here. And as they spoke earlier, there was some really good presentations earlier today that I really was taking note of, because I am thinking about, being a guy that used to worry about this stuff. I do think about how we're going to solve more than one problem as we try to increase the our capabilities to have more ubiquitous sensing in the boundary layer, and how that translates into, picking up more microclimate effects that are going to be really critical for the UAS. But we also know helicopters, we still know we don't have the best capabilities there, right? I mean, people still get in trouble, like we saw in California. And so the question becomes, how do we, move the whole industry forward in better weather and take advantage of the UAS opportunity that says, hey, we do need better capability. So and we have a requirement now that's harder. So let's take advantage of that requirement to drive improvement across the board. And so the VWAS thing, that's a really good initiative, and I like the idea of the cameras. And I'm still concerned about the cost, right? I think honestly, if we don't get those down to like 10,000 each, at least 10,000, then we're not going to see the kind of coverage that I think is going to be necessary to really support the UAS industry at the level that, we'll always make do with what we have, right? What will happen is we'll just wind up having more uncertainty, and we'll wind up grounding people more or increasing the risk of flight. And then by grounding them, we're going to impact their ROI. We're going to impact the industry's ability to make money. These are not big margin industry right now. And so yeah, we'll always survive with what we have. The question is are we, how's the industry then going to be able to grow and really reach its full potential if we cannot do a better job of getting the uncertainty down and creating more certainty in the boundary layer. So that's kind of, I think my focus. I've taken this on kind of as a cause because I, have the government background experience, and I understand the labs, and I understand the private sector now, and I understand the industry, and I'm trying to see how we can just bring everything together, right, and get a real good effect. Next slide. So, this slide here I always show because it's really important to always remind ourselves that the current capabilities that we have in our aviation weather services do not work for the UAS industry. And this was the FAA Lincoln Lab study. And I'm not going to, we're not going to continue to drive this home, but I would say that when you get into the urban environments, it's even worse, right? So we just need to keep in mind that this is our grading. This is where we are right now as an industry, as a weather industry, in our grading for the UAS. And this doesn't really give us the micro grading scale for the urban canyons. Next slide. So what is it I've seen? TruWeather's now been 2 years in the test ranges. We've been supporting real operations. We're actually supporting a flight today, actually tonight, tomorrow in Korea. They're flying some masks from the main island south of Korea to some small islands, and we ran some micro model stuff for them, and they're going to be collecting data for us. And what we're really starting to learn about impacts of wind aloft, even in visual line of sight. The threats are the invisible threats. It's not, we all could see precipitation coming. We all, they can get them down in time if they see precipitation, but the issues are what's really going on at 200, 300 feet. And when you see, I like to call them treetop inversions, especially in North Carolina. Some of us are meteorologists that have a lot of experience forecasting East Coast and understand cold air damming and low level jets, and they really set up nicely in North Carolina. And sometimes it could be 200-300 feet above the ground, at 30 knots, and it could be calm at the surface. And we've seen some of that in New York. We actually had an accident due to it, and it was a crashing inversion coming down from 2,000 feet. Originally, we had a PIREP at Syracuse at 6 a.m. of wind shear at 2,000 feet, 30 knots. It was a really interesting inversion. It was very strong. I was very surprised that it even set up as strong as it did. But what happened is folks went out to the airfield. They did everything the Part 107 said you're supposed to do. They were at Griffiths, so they had an ASOS. They had their handheld Kestrel, and they went out at 10 o'clock. We had warned them about the inversion, and that was going to come down. They flew 2 missions up to like 150 feet, no issues, winds were calm. And then in the third mission, they hit 100 feet and the inversion was coming down, and they nailed it. And the rotaries from that inversion overtook the aircraft's ability to, be airworthy, and it crashed. And, from my perspective, this is going to be, one of the more significant dangers that we're going to see, because you can't see it, right? And we don't have enough data to capture it. Next slide. So, when it all starts with observations, and this is from the World Meteorological Society. This is a great image of our sensing suites that we have out there. It takes a village, right? No one's sensor answers. You can't, you have to have, latency. You have to have aerial coverage. You have to have, right? I mean, it's just, and you have to blend them in a way that's going to give you the best picture of the atmosphere. And remember, when it comes to UAS, it's not about the surface data. It's more about what's going on aloft. And most big airplanes, the inversions are a bump, right? But in this case, they're not bumps. And those winds are also impact battery power and how far they can fly. And, I'm not going to say that they're going to go up there and fly a mission and run out of battery because they're not aware of the winds. But if they have a mission plan and they're trying to make money as a company, and they get up there and the winds are stronger than they expected, they've just lost money. And the other thing is it does happen where they crash them. Off of North Carolina last month, the emergency managers flew a DJI drone off the water off of North Carolina beach, and they went out and they were doing their stuff, and they came back. They had a 15-knot headwind, and they had to crash it in the water shore to shore because they didn't know that the winds were that strong, and they didn't account for the distance, and this was visual line of sight. So again, it is about the data. We need better data. Models will get us so far. Somebody this morning talked about RTMA. Hey, look, I'm a big RTMA fan, all right? But RTMA is based off of an analysis of a model, and it's not necessarily real-time in situ data. And what we're finding is when you're in these valleys and you're in these areas where there's no observations and the model is and the area subgrid to the model, it's, you know, you can get caught with your pants down because of these the weather sensitivity of these small aircraft. It is enough to cross you over a threshold. Next slide. So, you know, everybody in this room is smart enough to know that there's solutions out there. You know, this is not going to surprise anyone, but what I'm seeing right now is, you know, we really have got to open our mind to IoT data sets. And I think this morning, somebody, you know, said something that I wrote down because I liked it and I wanted to drive it home. They were talking about how you know, there's observation sites. He was talking about Duluth, I think, and there was observation sites that, you know, we know that the ceiling and visibility measurements aren't necessarily, you know, the caliber of certification that we look for. But we also know the error rates and that data could still be useful in certain scenarios. And the same goes for other parameters coming off of that site. And I really believe we've just got to learn how to use data smartly. We've got to get off of this idea that we have to certify everything to AWS or, you know, ASOS quality. We've got to think about how do we use data and calibrate it and validate it and smooth it and figure out, you know, what's usable in what scenarios and have a risk-based approach to data. Because if we try to be perfect and we have $120,000 VWASs, we're not going to solve this problem. So, you know, that's just one of my things that I'd like to see us continue to think about. How can we do that? Maybe that needs to be part of the research that Kevin's pushing, right? Maybe we need to look at how we use IoT data sets, you know, and make it useful to what we need, right? You know, we talked about cameras this morning, and I think it's really amazing, you know, that Alaska, what you're doing up there, and I really like to see some of that camera technology. And you know, I'd love to get some of that VWAS stuff in New York and other test ranges we're working in, because, you know, we can validate that stuff. We can use it in our testing with the FAA and with other operators. We use the Helios. We do use Helios in our system. There's also low-cost observation stations that might be good enough that don't have to be $120,000. It all depends on what you want to measure, right? The weather drones, you know, is another area that you know, we have a partnership with Meteodrone in Switzerland, and they were tested by NOAA and my good friends down at NSSL, and they have 2,500 hours flying beyond visual line of sight in Switzerland, and they've already demonstrated that they can improve the forecast for ceiling and visibility around Zurich Airport. And Meteo Swiss has written a paper about it. So, I mean, I'm not sure, you know, we can't have these everywhere, but, you know, I think they're part of the solution. And then you got GPS RO and commercial satellites. And again, we know GPS RO is attenuated in areas when it gets close to the surface, but, you know, again, it's part of the solution, right, of trying to get more observations, higher density, and we got to, you know, take advantage of those observations in a way that they just don't get lost in the model. Maybe there's a way that we can pull that data and turn it into useful soundings or useful information to try to get us a better real time. Maybe it could be part of a 3D RTMA. I don't know. I'm just throwing ideas out. Next slide. So I think, you know, where I'm really encouraged right now is, again, FAA, academia, and research and commercial coming together. And I think, you know, what I've really been trying to do for about a year now is get weather on the radar scope of the ASTM F-38. This is where all the standards for UAV, UAS in the United States, and it's being actually, you know, introduced around the world. They're considered we're considered a leader and in this, and in Switzerland they're using this, and in other places. So it's a really important group, and they've been doing a lot of work on UTM standards, right? Like, you know, how are you going to deconflict aircraft? How far apart do aircraft have to be? You know, how are we going to get two UAS traffic management service suppliers to be able to share information about the flights that they're bringing into the system from their users and making sure that they deconflict with each other and in a flight plan. And again, the key point to drive home here is the FAA made a decision and NASA made a decision that they had to outsource and a federated approach to UTM. They had to do it because they knew that the FAA could not do all of that below 400 feet. And they built a system by which Class G airspace is basically going to get, I won't say managed because the FAA doesn't like that word because they manage everything, but it'll be monitored and surveilled, and the users will be getting services from these UTMs who will then tie back into the ATM system, right? And around areas where you have airports, there's it's called Lance, and there's another method there to kind of deconflict manned aircraft. And there's a whole bunch of this stuff being developed. And I've been sitting in these meetings for almost 2 years, and I really understand that what they're trying to do. And I've been dying to say, hey, look, when are we going to get weather into this? So finally, about 4 months ago, Phil Canoe, who used to be NOAA, in charge of, I think, the whole NOAA fleet, he runs the ASTM, and he got us, you know, he agreed to take this forward, and we put together a group. Right now we have about 30, and it's open to anyone. And we had our first meeting as part of the ASTM F38 virtual annual meeting, and we actually had our own session. And we have people from Airbus, Peter Sachs, we have Ted Lester from GE Aeros, we have Justin is on there from UPS, we have Jeff Massey from Amazon, we have Uber, Rohit, and we have many other outsiders that are not just weather, but we have industry in there with weather. And we're now, and proudly, we got Kevin and Marilyn on there, and they were a huge component of helping us. We actually drafted the first terms of reference that are going to help us become a group and hopefully be accepted by the XCOM to be a group. And then in that group, we will be broken up into working groups and starting to develop recommended standards and performance standards for weather for the UAS industry. And we'll be doing it in the same construct that the rest of the UAS industry is doing it in. So we're like at the table with the big boys. And we are now getting pulled in. I just got an email today from another group that said, hey, we need to start bringing the weather subgroup into this other group at UTM. And so the point is that we'll be working to develop these standards with the FAA, with NASA, with anybody, and then we'll have to, you know, develop a consensus and develop a first draft of these standards. It's, you know, we're not going to solve world hunger in the first round. What we've got to do is we've got to try to be innovative enough to move the ball down the court, but not too far-reaching that we can't execute, right, what we need to execute. And so that's what we're working on, and you're all welcome to join us. And I think that, again, this is really a big deal for the weather industry to be at this table with the big boys. And so we need to, you know, encourage everybody to get involved, to help us. And let's also, this is going to drive requirements, and these requirements will drive research money. And, you know, this is how we can really have an effect on the system. Next slide. So, you know, I just wanted to talk about the importance of micro weather predictions. And again, you know, when we talked this morning about RTMA, we talked about LAMP, we talked about challenges in Alaska with subgrid ceiling and visibility predictions when you only have one station and it's driving the whole problem. You know, we got a lot of things to work, but you know, I think the key point of this slide is to demonstrate again the 3-kilometer HRRR on the left around Blacksburg, Virginia. You know, this is the same model on the right. We use the same name list as the HRRR, and you can see it's starting to pull out the mountains and the valley winds. And this is all hidden right now. If you know, and when people go out and they fly and they go, those weather guys, they really suck. I mean, geez, these winds are, you know, 14 knots at 80 meters, not, you know, 7 knots or whatever. and they get really upset because the batteries, and they, that's like a 50% reduction in flight time. And it's not because we're not that good. It's just that they're not getting what they need because we can't, we're not producing it and getting it out. And, one of the things that, I'm really trying to drive home is, people are going to have to start paying for better weather information. It's just not going to be free, and that if it's going to become a business model for them where, look, if you guys are worried about your ROI and keeping your aircraft up in the air, you're going to have to pay for better weather data. And it costs money to run these models. It's not free. And it's not going to come from the government in the time frame that you care about. So, this is where we need to, start looking at how we get user fees into the UTM system. And, we start getting folks to pay for these. And this is why the private sector has to be part of, the SDSP, because the private sector can be agile enough to fuse a lot of different data sets, make it available in the formats needed, do the decision tools, and even run their own micro models that can help, at least in the interim period, until we build the Uber, weather model that comes from somewhere, right? We know if we don't encourage the private sector to take that role, then we're going to be lagging behind our capabilities that we could deliver to this industry, and we're just gonna, we're going to hurt them, and we're going to hurt our own reputation. Next slide. And this is just an example of some products that they like they love the Routecast on the left. This is a product where you can take their waypoints and the takeoff, landing, and height and altitude, and we produce this using the micro model data and it also gives them an optimized route. And when you're really getting down to 5 knots of wind plus or minus, that could really hurt a mission. They really appreciate when you can do this kind of stuff. Next slide. I think one of the main points is that everything that we're doing in this industry is all new, which is really good, right? We don't I've worked in manned aviation industry. I know how if you had to work in United or Delta and you have all those old software systems, and if you wanted to get weather integrated into a interface, it would be take an act of Congress and $1 billion in 2 years because you had to rewrite the code and all that. But the times have changed. And everything's built on modern architecture. We have open data sources, open data sets. We're going to use the AXTM standard for API, which is the same AXTM is what we use, in manned aviation. The SAS cloud standards are starting to come together, and doing this is not rocket science. And what we don't want to do is put up our own artificial hurdles because of our because of our culture or because of the way we've done business for the last 40 years. We've really got to, break the paradigm on this. And, there are weather companies that are doing this right now. And so we just need to be thinking about how do we take the best of the government, the best of the academia and research, and the best of the private sector, and how do we come up with a roadmap that we know as an industry 3 + 3 + 3 = 20. And even on the research side, as Kevin was talking about this morning, we don't want to do research we don't need to do. We need to focus on where the gaps are, what the private sector can do and what they can't do, what the government can do and they can't do, and then go to the research and say this is what we need. Because if we start having stovepipe programs that are just going out there doing research willy-nilly because it's a fun thing to do or it's exciting, we're not putting our resources against the biggest need, and it's not coming together as an industry, and we need to do that. Next slide. And of course, this is Mateus, this is his big thing, of course, like mine. What are we going to do about this problem, right? And there's a lot here to deal with. This is not a good problem. We really don't have an operational system that can turn stuff around like this and be reliable and do it in every city across the world, right? We don't have that, and we got to build that, quite frankly. Next slide. And, you know, we know what the challenges in the urban terrain is. And I talked to Uber, I've talked to these guys. I know what their business model is. I know what their, how far out in the future they need to worry about stuff. I know the kind of things they're worried about. And, you know, we need to be focusing on the right problems is what I'm saying, right? Like in the major cities, you know, the heat island effect is huge, right? So if you're flying from Manhattan to JFK, you're going to go from Manhattan in August, you could be going from, you know, skin temperatures of 130, 140 degrees in the sun over the bay in Brooklyn, where temperature is now 70 degrees, and then, you know, landing at JFK. What about your density altitude in the cities? What about your weight? How many people are you going to put in that aircraft? Are you going to put the weight of those people in that eVTOL based on the temperature at JFK? So now you're making your plan for weight based on the wrong temperature, right? We got to think about all these things that are not something we normally think about in this industry and in the aviation industry. Next slide. So that was my spiel for today. I hope it was helpful. You know, if you have any questions, you know, please feel free to contact me, or, you know, we can answer questions now, whatever you want to do. Thank you.
Yeah, we do have that have been submitted here. David Kovacar is asking, are UAS pilots able to use vertical wind profiler data to monitor low-level winds?
Well, I guess the question would be yes, if you had it in a format that they can use and ingest and manipulate. And, you know, remember, when you're a UAS pilot, you may have somebody who has been a manned aviator or maybe never been a manned aviator. You have people who may have had no weather training other than the Part 107 weather training, which is not at all relevant to what they're trying to do. So you got to think about, it's not the data necessarily. I mean, yeah, of course, if you had vertical profiler data, it'd be awesome, right? But we don't want to give vertical weather profiler data to the end user. We've got to find a way to get it packaged and delivered in a way that they're going to be able to use it, integrate it, understand it, and make use of it. So I think the answer, of course, is yes, but I think there's a lot there you have to get, you know, to get that delivered that's a big, we're not even close. It's a big lift.
All right, and Jeff Massey had a question about what are the weather sensing capabilities and accuracy of Meteodrome observations?
Oh, well, I don't have all the specifications at my fingertips, but what I will tell you is that NOAA published a paper on Meteodrome. It was Steve Koch. That was all done independently, and you could go to the website for Meteodrome to read about what they claim to be the specs. Now, here's the thing. Meteodrome has been now selected by the Joint Special Operations Command in the military. So there's a vetting process there too. And the fact that they're gotten through that vetting process, they're actually delivering several Meteodrones here shortly. So, you know, I'm very convinced that this is the best drone that's commercially available that can have immediate operational impact. Let's put it that way.
And Justin Hiller did put a link on the comment on the meeting chat there. So anybody that wants to go to that, the link is been posted on there. Gary, you had some comments, questions. Do you want to go ahead and just speak up, Gary, about
I can
user friendly?
Yeah, I guess with all this, it's not just Don, but I heard him say some of the stuff in his briefing as well with UAS pilots. Has some weather products will be really good down in valleys, others will be good somewhere else. And I heard this, you know, with VWAS, how it's giving you certain things, but it may not be identical to an ASOS in certain cases. And my concern is, and we've presented this before in the WITIC program, the pilots with the products that we've run tests with just some basic products out on avweather.gov, and they're not using them correctly as is. My fear is that some of these things really sound great for meteorologists, and listening to a lot of these discussions, The Mets seem to know what all these are and RTMA and how you'd use it there. What's the method, or how are you taking all these new products coming on that are giving kind of the same information but for different specialties to make sure not just pilots, even dispatch and other people that are not Mets, put them into a simple form that they really know these go, no-go decisions. Getting the information is great, but we've seen where a lot of the planning off this extra information sometimes doesn't do well. We showed some data last time where in 84 pilots, not a single person using basic weather planned correctly. They all flew into the clouds on their planning using more basic products than what are being showed here. So I'm a little concerned that this is great for Mets and maybe it'll help forecasting, but our UAS pilots, who I suspect probably may not be as good as GA with weather, are really going to be savvy to know what to use when.
Well, I think that's what I meant. I mean, that's why I said the vertical wind profile is useless to them, right? I mean, what I've been doing is working on these types of products you're talking about. We've been testing different decision go, no-go decision products, and thus far they seem to work pretty well. The best product is one that blends 20 different data sets into a simple no-go, no-go. And, the military's been doing that for years, and so it's not like rocket science. But the thing is that the problem is that, and again, I mean this, is that I think the government needs to focus on helping get the standards right, get the data, helping with the research, let the private sector work on the go, no-go stuff, because we're in the trenches and we're hearing that we're building those capabilities, and those are not hard to build, right? Once you know what the requirement is, and with good data fusion tools, it's easy. You can build, decision support tools that are very simple. It's really the challenge right now, though, is we just don't have good enough data, and we need to I think that's what, we need the government and the research guys to focus on, is how are we going to get, better information to put into those decision products. But I agree with you 100%. I mean, we can't confuse people with all this data. First of all, the other thing I want to mention is this is going to be a fully automated career field in 5 years. So there won't even be a pilot. The data is going to be all machine to machine, and it's all going to have business analytic rules for managing the drones. So, in the end, it's really going to come down to the data and how it's used in these business analytics to make those decisions, right? So pilots are, they're probably not going to be more than, at some point, they'll be controlling 10 or 20 missions, right, at an ops center somewhere, and they'll be flying out of drone boxes that are all automated. They can't take off and land by themselves, and they're not going to be following every mission. They're going to be focusing on, having a tool set that's going to tell them where the adverse conditions are, where things are going wrong, and then the human's going to get involved in that process to do what they have to do. So we got to be thinking like that also, right?
Thank you, Gary. And Andy's asking, didn't helicopters have to deal with the same temperature mismatch operating from Manhattan to JFK? How was that solved?
Well, I can let Rex talk to that, but I will tell you that, again, the weather sensitivities we're talking about and the weight and things like that, we're talking about being much finer. Now, Rex, are you on? Do you want to address how you handle density altitude in a vertiport in Manhattan?
Well, I've never flown in Manhattan, so I have to tell you that. I've flown at high altitudes and different DAs. A lot of it goes into your performance planning. When you look at where you're going to fly, you look at the weather for the day and take in a consideration what your weight of the aircraft is, what your environmental conditions are. Having flown in what you were talking about earlier, those areas with that large heat island, it is definitely something that you pay attention to when you come into urban environments. Going into Chicago in July, you knew you were going to get turbulence off the buildings because of the differential in heating. I would say the bigger and heavier the aircraft, the less impact that has. The smaller and lighter you are, the more impact you wind up having.
Right. So we're dealing with a difference in capabilities of these aircraft, and the fact that they're really going to be skinning down the weight of the airframes themselves because they're battery powered, and they're going to be putting people on them, and everything's going to be, the tolerances are going to be a lot tighter. The other thing is the FAA did perform some tests out in Nevada. It might have been UPP-1 now that I think about it. I can't, well, that was NASA, TCL-4. And they did talk about in Reno, they were having problems with density altitude on top of the buildings flying those drones in Reno because they were getting like 160 degrees at the skin, right? And that was being a factor. Now, these are things that, you know, can be worked through with infrastructure and trying to use certain types of paint. And there's all kinds of things you could do, right, to mitigate it. But the fact of the matter is I'm just trying to, you know, drive home the point that we're dealing with a different animal here that we've never had to deal with before.
Okay, and one last question that I have on here, Michael Split, and I'm going to let you ask because I can't quite make out what it's something about dollars for Uber resolution real-time ops modeling. So if you could decipher that for us there, Michael. And
all right, yeah. So, you know, and I don't know if this becomes a question of you target certain areas that are critical, but I mean, in some sense, we can't even afford a radio sound network that sends up 2 balloons a day at a very low resolution. And to have the kind of resolution we need for these, it would be, like you were saying, lots of dollars. What's going to drive all that money to be able to support that kind of need?
Well, again, I think it's gonna be, we have to be innovative and we have to think outside the box about risk. And there are areas, you know, right now we built a system for aircraft and manned aviation and a pretty standard system for observations that were based on specific cylinder areas of airspace. And we kind of just have one system, right? We have helicopters also, and they've been kind of left behind at times, right? So we haven't even really done a good job with them. But part of that is because they're manned, they're flown by men and people, and they could take a little bit more, right? So I guess we kind of accepted that as the price of business. We didn't really have the business model to drive major investments in things that we should have maybe. But in this case, you know, if you're flying drones and package delivery drones over, you know, upstate New York in a rural area, do you need the same observation network for safety purposes as you would need flying people in a eVTOL from Manhattan to JFK? Do you need to have the same level of quality of observation for a package delivery versus a flying people? I think we just need to look at this a little differently. It has to be a risk-based framework, and then we need to then from there say what's good enough, like we talked about earlier, for certain types of operations, and then focus where we spend the dollars on where, you know, the 80-20 rule, where it needs to be spent, where risk is high, where you're flying over people, maybe high density corridors. And I think that's the way we have to take this on. And that, again, is where research could be, money could be put in to look at that and figure out how to, you know, set it up so that we're spending, you know, we're not going to have unlimited money. I mean, we now got a $3 trillion deficit, you know, so this is not going to get funded by the government. I guarantee it. It's going to have to come through business. It's going to have to be incentivized. Municipalities, businesses and municipalities are going to have to be incentivized in states to put up networks. It's going to have to be pay for service. It's going to have to, the money is going to have to flow back into the observing, whoever the owners of that data are. There has to be some incentive. That money will be funded through the UTM services and through the SDSPs who are buying the data from these businesses that are, or these municipalities, and using it to build their products. They're going to have to pay a tax back to those guys. And then, you know, that's the only way I could see this. It has to be, you know, it's going to have to be done differently than anything we've ever done before.
Okay, well, if there's no more questions, I'll hand it back off to you, Matt or Gordy.